Most teams are building the same thing right now. One Copilot, one interface, one big model behind it, and the assumption that one smart system should handle everything that looks clean. But in reality, it does the opposite. It drives up cost, it lowers answer quality, it makes governance messy fast, because the issue isn't AI adoption, it's the model behind it. In this episode, I want to replace that model with a better one. A governed fabric of experts. We need an architecture where small models route traffic, specialists do bounded work, and your system actually matches the job. If you keep the generalist, you lock in cost sprawl and blurred accountability. And if you want more of this, subscribe. But first, we need to kill the old assumption. Why the generalist bot breaks at scale. The generalist bot sounds efficient because it gives everyone one place to go. One entry point, one assistant, one prompt layer. It offers a single ownership story, at least on paper. But the moment usage grows, that simplicity starts to crack. The bot is no longer answering one kind of question. It's trying to classify intent, fetch policy, and summarize documents all at once. Then it tries to extract fields, trigger workflows, and reason through ambiguity. Those are not the same job. That's where things break. Routing is one job, extraction is another, policy lookup is another, and when you push all of that through one giant assistant, you're forcing one model to play too many roles. The result isn't flexibility, it's interference. A lot of enterprise teams miss this because the first demo works, early traffic is light, questions stay simple, and the audience is usually forgiving. So the bot looks capable, it feels broad. And because it can answer something in most cases, people assume it can own everything. But broad coverage is not the same as operational fitness. A system that can attempt every task is not a system that should own every task. Now, one level deeper. Different tasks fail in different ways. A routing decision needs speed and low cost. A document extraction task needs structured output and consistency. A policy assistant needs bounded retrieval and strict access control. When one generalist handles all of that, you don't get one stable behavior. You get trade-offs hidden inside a single surface. This is why quality starts dropping as scope expands. The team keeps adding prompts, tools, and exceptions to the stack. The bot becomes a pile of compensations. It answers well in one area, but that same tuning hurts another. It behaves safely for one workflow, but now it sounds too rigid somewhere else. It can reason deeply, but it's too expensive for high-volume traffic. Or it stays cheap, but now it misses nuance where the stakes are higher. So what's actually happening is simple. The bot is overgeneralized. And overgeneralized systems create three kinds of debt. First, cost debt. When one assistant fronts everything, the safest choice is to run a premium model. The team can't predict what might come in, so they over-provision. That means easy work like basic policy answers gets priced like premium reasoning. The architecture treats every request like a potential edge case. That's expensive by design. Second, quality debt. The more jobs one bot owns, the harder it gets to keep answers sharp. Instructions get longer. Context gets broader. Tool choices multiply. The system starts blending responsibilities that should stay separate. Instead of a clean domain boundary, you get a vague assistant. It sounds helpful, but it often lands in the middle. Not wrong enough to trigger alarms, not precise enough to trust deeply. That middle is dangerous. Because enterprise AI doesn't usually fail with dramatic errors first. It fails with low confidence usefulness, slower than expected, more expensive than expected, less precise than expected. And because the interface still looks polished, the underlying weakness stays hidden. Third, governance debt. This is the part many teams leave for later, and later gets expensive. Once one bot spans too many domains, ownership blurs. Who owns the prompt behavior? Who owns the knowledge sources? Who reviews the actions? In a generalist model, those lines fade quickly. And blurred ownership is not a side issue. It is the system issue. In most organizations, governance works when purpose is narrow. A policy agent with a defined data scope and a named owner is governable. A workflow agent with restricted tools and approval rules is governable. A router that classifies and passes work on is governable, but a giant assistant sitting across every task becomes hard to reason about. Its purpose is just too broad. So the contrast we need is this: not one giant assistant that tries to know and do everything. A bounded expert system, one front door if you want it. But behind that, specialized roles, tight scopes, clear owners, model choice matched to task. That leads to structured handoffs and better cost control, better answers, better governance. And once you see that clearly, the cost story becomes impossible to ignore. The cost model most teams never map. Most teams talk about AI cost too late. They look at the bill after the rollout. They compare one model price to another. They ask if the premium model is worth the spend. But the real mistake happens much earlier, when nobody maps the traffic shape of the system before choosing the architecture. Because not all requests deserve the same model. In most enterprise environments, a huge share of traffic is routine. You are sorting a request or classifying an intent or extracting specific fields. Maybe you are checking a policy source, drafting a structured response, or deciding whether to escalate a ticket. None of that is frontier model work by default, yet many teams still run that traffic through GPT-4o class models as if every prompt were a board-level reasoning problem. That is where the waste starts. The research is very clear on this. GPT-4o sits in a premium pricing tier, and public data puts it at $2.50 per million input tokens and $10 per million output tokens. By contrast, recent comparison material places Phi-class small models in a much lower range, with examples around 7 to 14 cents per million tokens. Phi-4 pricing is also reported at about 12.5 cents per million input tokens and 50 cents per million output tokens depending on your provider. You don't need perfect pricing precision to see the structural issue. The gap is massive. So the question is not which model is smartest. The better question is, why is premium reasoning touching routine traffic at all? This clicked for a lot of teams only after they saw the first real invoice. They assumed the expensive part would be rare edge cases, but in reality, the high volume layer is usually the cheap work. It is classification, routing, extraction, and short transformations. If that layer hits an expensive model every time, the cost profile is already broken before the harder tasks even arrive. And one level deeper, token price alone still doesn't tell the whole story. What matters is blended cost. Blended cost is the average price of the full traffic mix across the entire path of the system. If you send every request to one premium model, your blended cost stays close to premium, even though most requests never needed that level of capability. But if a small model handles the first pass and only some requests escalate, the average drops fast because the expensive path is no longer the default path. That's the cheap first, escalate later pattern. The logic is simple. Start with the lowest cost model that can do the current job reliably. If the request is ambiguous, risky, or genuinely difficult, then pass it up the chain. If it is routine, keep it down. That one shift changes the economics of the whole system because enterprise AI traffic is not evenly distributed. Most of it clusters around repeatable work. The research even points to routing patterns where small model pipelines kept most of the higher-end quality while cutting costs sharply. One result describes intelligent routing between a small model and GPT-4 that preserved 95% of the quality while reducing costs by 85%. Even if your own workload lands differently, the direction is clear. Better routing changes the bill more than endless prompt tuning on the wrong model. There's another thing teams miss. They compare raw model prices, but they don't compare avoided spend. If a cheap router decides that no LLM is needed, that is not a small optimization. That is the best possible cost decision for that turn. A workflow can run directly, or a deterministic rule can answer, or a known source can be returned. Once you let the system decide that some traffic should bypass generation entirely, the economics improve again. And this is why AI builds feel unpredictable to so many leaders. The model is not just expensive. The path is ungoverned. Easy traffic, hard traffic, and sensitive traffic all collapse into one inference lane, so nobody can explain why costs rise except by saying usage increased. But usage is not the root issue. Cost shape is. You need to know what percentage of requests are simple, what percentage require retrieval, and what percentage deserve premium reasoning. Without that map, you are not budgeting for architecture. You are budgeting for hope. Cost alone would already justify a redesign. But the more interesting part is this. Smaller models are not only cheaper, in a lot of cases they're a better operational fit. Why smaller models win more work than people think. A lot of people still hear small model and assume second best. That assumption is old. It comes from a period when smaller meant obviously weaker across almost everything, so teams learned to think in one direction only. Bigger model, better result. But enterprise work is not one benchmark. It is a stack of repeated tasks with boundaries, formats, and expected outputs. Once you look at the work that way, the question changes. Not how smart is the model in general. How well does the model fit this exact job? That shift matters because many enterprise tasks are narrow by nature. Intent detection is narrow, triage is narrow, and structured extraction is narrow. Even a lot of summarization is narrower than people think because the format and the acceptable scope are already known. These are not open-world reasoning contests. They are operational tasks inside bounded systems. And bounded systems reward fit. This is where smaller models start winning more work than most teams expect. They don't have to beat larger models everywhere to be useful. They win because they are good enough where the task is repetitive, the inputs are familiar, and the output can be tightly defined. In those conditions, operational reliability matters more than raw breadth. Think about a router. Its job is not to produce a brilliant answer. Its job is to choose the next path correctly. It needs to read the request, classify the intent, and return a structured decision. That is a different standard. The best router is not the model with the broadest intelligence. It is the model that can make that decision quickly, cheaply, and consistently. Same thing with extraction. If you need fields pulled from a document or categories assigned to a ticket, you usually care about schema discipline rather than eloquence. You want the right structure, the right slot, and the right label. Smaller models can do that well when the task is designed properly. This is the part many teams skip. They compare models in the abstract instead of comparing tasks under constraints. In practice, small models get stronger when you reduce ambiguity, give them a defined schema, limit the domain, and keep the instructions tight. In some cases, the research even points to fine-tuned phi-class models outperforming larger models on narrow domain work. That should reset how teams think about capability. Bigger is not always better. Better bounded is often better. Latency matters here too. People usually treat latency as a user experience issue, which it is, but it also changes system behavior. Faster, low-cost decisions mean you can route earlier and keep flows moving without dragging every request through a heavyweight path. In agent systems, delay compounds. One slow choice at the front can slow every handoff behind it. So when a smaller model responds faster, that is not just a nicer interface, it is a cleaner operating rhythm for the whole fabric. Now, there are limits. If the task is broad, ambiguous, or carries a lot of hidden complexity, a small model may not be the right default. If you need long context synthesis across many sources or multimodal judgment, then a larger model may earn its place. The point is not to pretend the gap is gone. The point is to stop using that gap as an excuse to overbuy intelligence for every step, because the real architecture decision is not best model overall. It is best model for this task at this point in the flow under these constraints. That is a very different design mindset. It forces you to define the work more clearly, and it forces you to separate broad intelligence from operational fitness. Once you start doing that, the monolithic Copilot stops looking advanced. It starts looking lazy. Because in a governed system, model choice is part of the design, not a default. And once that clicks, the architecture itself has to change. What mixture of experts really means here? So now we can name the shift properly. When people hear mixture of experts, they usually think about one thing. They think about a model architecture where a gating mechanism activates only specific internal experts for each token. That is real. The research supports it. Microsoft's 2026 model direction includes sparse MoE models like MyThinking1, and we have already seen Phi 3.5 MoE surface through Azure AI Studio and GitHub. At the model layer, MoE simply means sparse activation inside the model itself. But that is not the main thing most Microsoft teams will actually build. That distinction matters. Because if you go looking in Copilot Studio for a big button labeled Turn on MoE, you won't find it. And if you expect Foundry to hand you a magical MoE orchestration wizard, that is not really how the platform is framed either. The practical Microsoft story is much more architectural. You choose models, you deploy them in Foundry, and you connect logic with prompt flows, agent patterns, endpoints, and routing decisions. Then you govern the whole thing. So what's actually happening is this. There are two layers of MoE thinking. One is model-level MoE that lives inside the model design itself. Sparse experts. Internal routing. Capacity without activating the full parameter set every time. It is useful and powerful, but it is mostly abstracted away from the average enterprise builder. The other is system-level MoE. That is the one most organizations can act on right now. A system-level mixture of experts means your application chooses among different specialized models, agents, tools, and paths based on the job at hand. One request might go to a small classifier, while another goes to retrieval, and a third might trigger a workflow directly or escalate to a premium reasoning model. The experts are no longer hidden inside one model. They are explicit parts of the architecture. And this is the shift that changes design. Because once experts are explicit, selection becomes a governance decision rather than just a model behavior. You decide what counts as an expert, you define its purpose, and you restrict its data. You assign its owner and decide what can call it, what it can call, and exactly when it should stop. That is a very different operating model from one large assistant improvising across everything. In Microsoft's stack, Foundry becomes the place where model optionality and routing logic start to live. It is where you host models, evaluate them, connect data, and build prompt flow logic while increasingly managing routed patterns like Model Router. Copilot Studio sits closer to the user interaction layer. It manages conversation, workflow surfaces, and channels while handling multi-agent orchestration patterns at the product level. These are complementary layers, not competing ones. That's where people get confused. They ask whether Copilot Studio or Foundry is the MoE answer. It's the wrong question. MoE here is not one product, it is the pattern formed across them. Foundry gives you model control and routing options, while Copilot Studio gives you the governed experience surface and orchestration entry point. Agent patterns connect the pieces, and policy and monitoring hold them together. That combined shape is the practical enterprise form of mixture of experts in Microsoft land. You can think of it as an agent fabric, but keep it concrete. A user asks for help. The front door layer captures context and intent. A routing layer decides what kind of work this is. A specialist path handles that work with the right model, tool, or agent. The result comes back in a controlled format. The system logs the path, enforces policy, and keeps ownership clear. That is system-level MoE. And the reason this matters is simple. It turns expert selection from a hidden side effect into a designed capability. You stop hoping one model will stretch far enough, and you start building a fabric where specialization is normal, observable, and governable. That's the real meaning here. Not one magic model, not one shiny feature. a structural choice about how intelligence is distributed across the system. And once you see MoE that way, the next question is obvious. Which part belongs in which layer? Copilot Studio is the face, Foundry is the brain. This is where a lot of projects start drifting. Teams get excited about Copilot Studio because it is close to the user. You can shape the conversation, connect actions, and publish to channels to get something visible fast. That speed is useful, but it also creates a trap. Because once the interface works, people start putting deeper model logic into the same layer, and that is usually where the architecture starts getting muddy. Copilot Studio should be the face. It should handle the conversation layer, the workflow layer, and the channel layer. It is where users enter, where prompts become interactions, and where business context and input collection happen in a way people can actually use. In Microsoft's own direction, Copilot Studio keeps getting stronger as the user-facing agent surface across Microsoft 365, Teams, web, and business workflows. But user-facing is not the same as model governance-facing. Foundry sits in a different part of the stack. It is where model selection, deployment, evaluation, prompt flow logic, and routing capabilities belong. It is also where you get closer to benchmark-driven decisions, model catalogs, and the operational controls that matter when more than one model or agent path is involved. If Studio is where the interaction happens, Foundry is where deeper reasoning infrastructure is shaped and tested. That split is not cosmetic. It affects how cleanly the system can grow. What typically happens is this. A team starts with a Copilot Studio agent, but then they keep adding more responsibility into that same surface. They add classification logic, prompt branching, and complex model decisions alongside retrieval experiments and external backend calls. Soon the experience layer is carrying reasoning responsibilities it was never meant to own directly at that depth. The result is not just complexity, it is hidden complexity in the wrong place. That is the brain in the face mistake. You are putting architectural intelligence where presentation logic should dominate. So the conversational shell becomes the place where model strategy lives, and then changing models or evaluating routes becomes much harder. Reusing expert logic across agents becomes difficult, and governance gets weaker because critical decisions are buried inside a user flow layer instead of living in a platform layer designed for model control. The reverse mistake happens too. Some teams stay entirely in Foundry because that feels more serious, more technical, and more flexible. They build model flows, endpoints, and evaluators, but they under-design the user layer. Then the system may be clever, but it is not usable. It lacks the right front door, the right clarification moments, and the right workflow framing for actual work. People don't just need a smart endpoint, they need a governed experience. So this is not Studio versus Foundry. It is Studio for experience, Foundry for reasoning control, and both connected on purpose. That means the split needs to be explicit. Let Copilot Studio own what the user sees and how the user moves through the interaction. Let it manage the conversational frame, the channel behavior, the action handoff points, and the bounded orchestration patterns that shape the journey. Let Foundry own what the system decides and how the underlying intelligence is selected. Let it host the models, manage prompt flow or agent logic, support evaluation, and expose rooted backends to keep model choice testable and governable. Execution sits beside both. Because once an action needs to happen, the flow may pass through Power Automate, connectors, APIs, or external services. That action layer is not the same as the conversation layer, and it is not the same as the model layer. If you keep those concerns separate, the whole system becomes easier to evolve. If you collapse them, every change touches everything. And this matters even more once you move into an expert fabric, because specialized systems need clear seams. The front layer should not need to know every model detail, and the model layer should not be forced to manage every user nuance. Good architecture lets each layer stay focused. Once the layers are clear, the first expert almost picks itself. Not the answer model, the router. The first expert should be the router, not the answer model. If you are moving from one generalist bot to an expert fabric, the first expert you add should not be the smartest answer engine. It should be the system that decides what kind of work just arrived. That sounds less exciting, but it is where the architecture starts getting disciplined, because the first decision in the flow shapes cost, latency, control, and quality for everything that follows. If that first decision is wrong, you pay for it all the way down. If it is clean, the rest of the system gets simpler. Most teams still do the opposite. They start by picking a big answer model, then they add prompts, retrieval, and actions around it. The expensive reasoning layer becomes the default entry point for every request, even when the user is just asking for a simple sort or a workflow trigger. That is backwards. The front of the system should decide. The premium layer should answer only when the system has a reason to spend that capability. So the router becomes the first real specialist. Its job is narrow: read the request, classify the task, judge the likely path, return a structured decision. It might identify the domain, the risk level, or whether a larger model is even justified. This is a very different role from open-ended generation, and that is why it deserves its own design. In practical Microsoft terms, this can live as a low-cost model pattern inside Foundry logic or inside a governed orchestration path that Copilot Studio triggers. The exact placement can vary, but the function is what matters. You want a first-pass layer that is cheap, fast, and measurable. This is why phi-class models make sense here. The research supports using small models for routing heavy work, especially for classification and structured decisions. You are not asking the model to compose a nuanced executive answer. You are asking it to make a limited call about what should happen next. If it returns a schema like task type, complexity, and confidence, you can govern that output cleanly. That structured output matters a lot. Do not make the router chatty. Do not ask it to explain itself in 3 paragraphs or let it improvise policy language. Make it return a compact decision object that the rest of the system can act on. That keeps the router stable and it gives you traces you can actually inspect later. Now, what should the router decide? At minimum, 5 things are usually enough to change the architecture. What kind of task is this? How hard is it likely to be? How risky is it? What domain does it belong to? And what kind of next step does it require? That next step may be a specialist model, a retrieval-backed agent, or a workflow. It might even be no model at all. That last option is easy to underrate, but it is one of the best outcomes in the whole design. If the system determines that a direct rule or a connector should handle the request, the router has just prevented unnecessary inference altogether. That is where the economics, performance, and governance story all meet. Cost improves because routine traffic gets filtered before it touches premium inference. Latency improves because narrow decisions happen quickly and the user reaches the right path faster. Governance improves because every request now passes through a decision point that can be logged and tuned. And one level deeper, the router gives you visibility you never get from a monolith. You can see where traffic goes, you can see what percentage of requests escalate, you can see whether teams are sending too much work into expensive paths. Without a router, all of that stays blended together. So if you remember one design move from this section, make it this. Do not start by asking, what model should answer everything? Start by asking, what should decide what this request actually is? Because once that decision gets its own specialist, the whole architecture stops behaving like a generalist with too many responsibilities. It starts behaving like a system. But that only works when the expert map itself is clean. How to define your expert domains. Once the router exists, the next design problem shows up fast. What exactly are the experts? A lot of teams answer that question with the org chart. HR agent, finance agent, IT agent, legal agent. Sometimes that works, but usually it only works partway. Departments are ownership boundaries, not always task boundaries. If you define experts only by department, you often end up rebuilding the same confusion you were trying to escape. One domain agent still tries to answer, retrieve, and act across too many different jobs. So split by task type first, then map to ownership. That is the shift. A useful expert domain is narrow enough that you can describe its job in one sentence, restrict its tools, and know when it should stop. If you cannot do that, the expert is still too broad. The point is not to create a smaller version of the generalist. The point is to create bounded roles that fit distinct work patterns. In practice, a few expert patterns show up again and again. A knowledge expert answers questions from approved sources. An extraction expert turns documents into structured fields. A policy expert interprets rules inside a limited corpus. A workflow expert takes approved actions in business systems. An analytics expert works with data questions and metrics. A coding expert handles engineering tasks or technical analysis. Those are task families. Then, inside the organization, you can decide whether one finance policy expert exists or whether finance needs separate policy and workflow experts. The split depends on risk, data sensitivity, and task variation, not just on which team has the budget. That is the thing most people miss. Domain does not only mean subject matter. Domain also means action pattern. A legal knowledge expert and a legal workflow expert may both sit in legal, but they should not automatically be the same agent. One reads and answers while the other does things. Those are different risk profiles and different permission needs. Keep them separate unless you have a very good reason not to. Boundaries need to be clear on 3 fronts: purpose, data, tools. Purpose means what the expert is allowed to try to do. Data means which sources it can see. Tools means which actions or systems it can touch. If one of those stays vague, overlap starts creeping back in. Then 2 experts answer the same question differently, or one expert starts reaching into a dataset it should never have seen. That overlap is expensive. It is not just about cost, it is about trust. Users stop understanding where the answer came from, and owners stop knowing which team is responsible for improving it. So write domain charters. Not long documents, short, strict ones. For each expert, define the mission, the allowed tasks, the blocked tasks, the approved data sources, and the tools. Add the owner. Add the risk level. Add the expected output format. This does 2 things at once. It sharpens the build, and it sharpens the governance. Segmentation matters even more when knowledge is involved. Do not point every expert at one giant shared index unless you are fully comfortable with the visibility consequences. In many environments, that recreates the same oversharing risk that generalist bots already create. Experts should see the knowledge they need and no more. Role and sensitivity boundaries have to shape the index strategy, not just the prompt strategy. There is also a maturity point here. Do not create 10 experts on day 1 because the architecture diagram looks impressive. Start where task differences are real and measurable. One router, one knowledge expert, one workflow expert, maybe one policy expert if that boundary is sharp. Then expand only when a new expert solves a real problem the current ones cannot handle. Good expert maps feel slightly strict at first. That is a good sign, because narrow missions create cleaner routing, clearer ownership, and better evaluation later. Loose missions create polite chaos, and once the expert map is defined well enough to survive contact with real traffic, you can finally design the flow through the whole system. The base architecture for a governed expert fabric. Once the expert map is clear, the next job is to design the path through the system so those experts operate like a governed fabric instead of a loose collection of clever parts. This is where architecture stops being abstract. A user sends a request, the system captures context, a route gets chosen, work happens in a bounded place, results come back in a controlled form, every handoff is visible, start at the front door. In the Microsoft stack, that front door is usually Copilot Studio or a Microsoft 365 Copilot extension point. That is where the user interaction begins, and that matters because the first layer should not only capture the words in the prompt, it should capture the operating context around the prompt. Who is the user? What channel are they in? What app are they using? What role do they hold? What environment are they working inside? Are they asking for information, analysis, or action? Those signals shape what the system is allowed to do next. So the first layer is really an intake layer. It does not need to be dramatic. It needs to be disciplined. Intake should gather four things well: intent, context, identity, and environment. Intent tells you what the user seems to want. Context tells you what surrounding material may matter. Identity tells you what access model applies. Environment tells you which policy zone you are inside. Without those four, downstream routing turns into guesswork. After intake, the router decides the path. This is the structural pivot in the flow. The router does not answer the user directly unless the architecture explicitly allows that for narrow cases. Its main job is path selection. Maybe the request is simple enough for a direct answer. Maybe it needs a retrieval-backed knowledge path. Maybe it needs a workflow path. Maybe it belongs with a specialist agent. The point is that the system chooses the type of work before it chooses the answer. And one level deeper, different paths should produce different kinds of outputs. A specialist should not return a long conversational essay unless that is truly the point of the specialist. In most enterprise flows, the better pattern is structured output. The knowledge expert returns answer, source, confidence, and citation. The extraction expert returns fields and validation flags. The workflow expert returns status, required approvals, and execution result. The analytics expert returns metrics, assumptions, and scope. Structure makes orchestration cleaner, and it makes audit much easier later. That means you need an orchestrator after the expert step. The orchestrator is responsible for assembling the final user response and deciding whether any action should be presented, delayed, or blocked. It takes the specialist output, combines it with policy and presentation rules, and turns it into one coherent user-facing response. This is why one user-facing voice still matters. Even in a multi-expert system, the user should not feel like 5 different systems are arguing in public. The system can be distributed behind the scenes while remaining consistent at the surface. Now add the controls that wrap the whole thing. Every handoff should generate logs. Every expert decision should be traceable. Every action request should carry policy context. Every connector call should be attributable. Prompt, route, tool use, output, and outcome all need to be captured in a way that security, compliance, and platform teams can actually inspect later. If the path is invisible, the fabric is not governed, it is just complex. This is also where state discipline matters. Do not let critical control information live only inside transient model context. Externalize state where possible. Keep route records, approvals, intermediate outputs, and execution history in managed systems where they can be audited and controlled. Hidden memory creates hidden risk. Managed state creates operational clarity. So the base architecture looks like this. User enters through Copilot Studio or Microsoft 365 Copilot. Intake captures identity, context, intent, and environment. Router selects the path. Specialist performs bounded work and returns structured output. Orchestrator assembles the response and action. Logging, policy, and trace wrap every step. That is the shape. Not because diagrams are nice, but because governed systems need deliberate seams. And once you have that shape, the next design issue shows up immediately. Retrieval has to live inside the fabric properly, not float beside it as a separate idea. RAG is not the expert, it is one capability inside the fabric. This is a place where a lot of enterprise AI discussions get fuzzy fast. People say they are building an expert system, but what they really mean is they added retrieval. They indexed some content, connected search, and now the assistant can pull documents into context. That can be useful, but retrieval is not the same thing as expertise, and when those two ideas get merged, the architecture starts drifting again. RAG solves a different problem. It helps a system reach external knowledge that is not already inside the model. It improves grounding, it helps with freshness, it helps with citations. It helps the system pull relevant context from documents, records, and indexed sources. That is a knowledge access pattern. An expert is something else. An expert has a bounded mission, a decision role, a stop boundary, and a clear output shape. It may use retrieval, it may not, but retrieval by itself does not create specialization. It only creates access. That distinction matters because a lot of teams build one giant retrieval chain, point every agent at it, and then call the result an expert architecture. It isn't. It is still a broad assistant with better document access. So the better pattern is this. Treat retrieval as a tool that an expert can use. A knowledge expert may call retrieval. A policy expert may call retrieval against approved policy sources. An analytics expert may call retrieval for report definitions or metric descriptions, but the expert still owns the task boundary. The retrieval layer stays subordinate to the role, not the other way around. That keeps the design clean. It also keeps the governance cleaner, because once retrieval is attached to a bounded agent, you can control which corpus that agent can search, which filters apply, what sensitivity rules matter, and what kinds of outputs are allowed. If retrieval stays centralized and shared without clear scoping, the system starts recreating the same oversharing problem that generalist bots already trigger. One giant index feels efficient. In practice, it often means one giant visibility surface. And this is why modular RAG fits better inside an expert fabric than one monolithic retrieval pipeline. Modular RAG means retrieval is built as a capability that can be composed differently depending on the expert and the task. One expert might use vector search over curated knowledge articles. Another might use graph-based retrieval because relationships across entities matter. Another might use hybrid retrieval because exact policy wording and semantic similarity both matter at the same time. The retrieval strategy should follow the task pattern, not the branding of the AI program. That is a design choice, not a default. If the question depends on entity relationships, graph retrieval may be the better fit. If the corpus is large and language is varied, vector retrieval can help with semantic access. If exact phrasing matters, especially in policy or compliance scenarios, hybrid retrieval often makes more sense because it blends semantic and keyword style access. The point is not to turn every agent into a retrieval science project. The point is to stop pretending one shared retrieval method is automatically right for every job. A second reason this matters is traceability. When retrieval lives inside a bounded expert, you can inspect which source was searched, which documents were surfaced, what filters applied, and how that context influenced the answer. That makes review easier. It also makes tuning easier. If the knowledge expert performs badly, you can fix the knowledge expert. If the policy expert retrieves the wrong material, you can tune that path specifically. In a giant shared retrieval chain, poor behavior spreads across many use cases and becomes much harder to isolate. So remember the hierarchy. The expert owns the task. Retrieval supports the expert, not the reverse. Once teams get that right, the architecture becomes much easier to govern because data access is no longer treated like a universal pool. It becomes part of a bounded role. And the moment data starts getting segmented that way, governance stops being something you add later. It becomes part of the structure from the beginning. Governance changes completely in multi-agent systems. When you move from one agent to many, governance stops being a side layer and becomes part of the runtime design. That is the shift. A lot of teams still think in old terms. They focus on prompt safety, output filtering, and maybe a few blocked words. Those controls still matter, but they belong to a simpler world where one model answered one question and stopped there. Multi-agent systems do not work like that. They read, they route, they call tools, they hand work off, they pull data from different places. They might trigger workflows or involve different identities and permissions in the same user journey. Because of this, the risk surface is no longer just the answer, it is the whole chain. That changes everything. The failure point might be the route, not the response. It might be the wrong specialist receiving the task, or perhaps a connector with too much access. It might be a handoff that loses context while keeping authority, or an ownerless flow still running in production. It might be a model switch that nobody reviewed, or a transcript gap that leaves security teams unable to reconstruct what happened. In a multi-agent setup, weak control usually shows up between components instead of only inside one. So the first governance question becomes inventory. What agents exist? What models do they use? What flows do they trigger? What connectors do they hold? What data can they reach? Who owns them? What is their purpose? When do they expire? If you cannot answer those basics quickly, you do not have a governed agent system. You have agent sprawl with a nice interface. The research is very consistent on this point. Inventory is not admin overhead, it is the foundation. Without it, you cannot do lifecycle control, permission review, incident response, or meaningful risk assessment. Ownership has to be explicit too. Not the AI team in general, not IT in broad terms. A named owner for the front door agent, a named owner for the policy expert, a named owner for the workflow path, a named owner for the data source. The moment a routed system crosses departments, accountability gets blurry fast unless you force clarity into the design. Blurry accountability is how risky automations survive longer than they should. Permissions become even more important here. In a single agent world, people often debate model quality first. In a multi-agent world, least privilege is usually the sharper control. An average model with tight permissions is easier to contain than an excellent model with broad access and vague tool rights. The biggest harm often comes from what an agent can reach or trigger, not from whether its wording is elegant. If one specialist only needs one site, one table, and one action, give it exactly that. Nothing wider. Logging has to expand as well. Final answers are not enough anymore. You need prompts, routes, tool calls, handoffs, actions, outcomes, and timestamps. You need enough trace to answer 4 questions later. What happened? Why did it happen? Which component decided it? And what data did it touch? If your logs only capture the final user message and final user answer, you are blind to the actual behavior of the system. This is also why deployment governance cannot wait until after launch. You need review gates before production. You need environment separation. You need different permissions in dev, test, and prod. You need policies around model approval, connector approval, and action approval before agents start multiplying. Once they spread through the tenant, cleanup gets harder, not easier. Multi-agent systems reward discipline early and punish improvisation late. And this is where the Microsoft conversation changes too. Because once governance has to span identity, inventory, policy, lifecycle, and oversight across many agents, you need more than good intentions and scattered admin settings. You need a control plane. That is where Agent 365 enters the picture. What Agent 365 changes and what it does not. So now we can place Agent 365 properly. A lot of people hear the phrase and assume Microsoft has delivered one master answer for agent governance. One place to switch everything on. One surface that solves inventory, policy, risk, identity, and runtime control in a single move. That is too generous. Agent 365 matters, but it matters in a more specific way. It changes governance posture because it treats agents as first-class managed things, not as random side projects, not as invisible flows, not as clever assistants floating around the tenant with unclear status. The research points to a few concrete shifts. Agent 365 brings a registry idea to the center. It gives each agent a managed identity pattern through agent ID concepts. It connects policy, ownership, lifecycle, and discovery into one governance surface. And it ties that surface into the rest of the Microsoft control stack, especially Entra, Purview, Defender, and the admin center. That is a real change. Because once agents become visible as governed identities, you can start asking better questions. Which agents exist? Who owns them? What permissions do they hold? Which data sources do they touch? Which tools can they invoke? Which environments are they running in? Which ones are experimental? Which ones are production? Which ones should have been retired already but are still hanging around? Without that inventory spine, enterprise agent governance stays fragmented. That is where Agent 365 is strongest. It gives you a place to anchor identity and oversight across specialized agents, including agents that reach into different services and workflows. In a routed architecture, that matters more than it would in a single agent setup because specialist systems multiply fast. The number of models, connectors, sub-agents, and delegated paths increases, and the chance of orphaned logic rises with it. Agent 365 helps reduce that blindness. It also strengthens policy enforcement through connection, not isolation. An agent ID can sit inside the larger Entra model. Purview can shape data controls around prompts, responses, and access patterns. Defender can monitor unusual behavior or risky relationships between agents and data. Admin surfaces can help discover, govern, and review what is active. That connective role is why I would call Agent 365 a governance spine. It does not replace the rest of the body. It gives the body structure. That distinction matters because expectations are running ahead of reality. Agent 365 is not a full cross-cloud answer to every agent problem. The research is pretty direct about that. Governance gaps still exist when agents move across external clouds, external runtimes, third-party tools, or partially integrated ecosystems. Visibility may weaken. Enforcement depth may vary. Some telemetry may still be incomplete. If your architecture spans Azure, Microsoft 365, outside SaaS, custom MCP servers, or other clouds, you still need deliberate design. Agent 365 helps, but it does not excuse sloppy boundaries. It also does not remove the need for charters. You still need to define what each agent is for. You still need owners. You still need risk tiers. You still need approval logic. You still need connector discipline and environment separation. If an organization treats Agent 365 as a reason to stop doing architecture, it will just centralize confusion more efficiently. So use it for what it is actually good at. Use it to register agents. Use it to anchor identity. Use it to apply policy consistently. Use it to support lifecycle reviews, discovery, and monitoring. Use it to connect governance across the Microsoft stack, but do not confuse a control plane with a complete design. A control plane can tell you what exists, constrain what is allowed, and help you stop unsafe things faster. It cannot decide your expert boundaries for you. It cannot magically clean up overlapping missions. It cannot turn a messy routing model into a clean one. Those are still architecture choices. And this becomes even more important once model choice itself starts varying across experts and routes. Because the moment you allow model optionality, you need governance not only over agents, but over which models those agents can use in the first place. That means the next layer is not agent governance alone. It is model governance. Use as your policy to control model switching. Once you accept that a rotated system uses several models, a new governance problem appears fast. Who gets to choose them? If every team can swap models whenever they want, your architecture stops being governed at the exact point where it becomes more powerful. A routed system without model policy doesn't stay flexible for long, and instead it turns into a moving target where behavior shifts and compliance reviews fall behind. Cost assumptions drift when nobody can explain why the same prompt behaves differently this week than it did last week. That's why model choice has to be a platform decision rather than a developer preference. This is where Azure policy matters. The practical Microsoft pattern in the research is very clear because Azure policy can restrict which models are allowed from Azure AI Foundry. It covers approved registries, model asset IDs, publishers, and deployment types, which means the platform defines the catalog where teams are allowed to operate. That changes the conversation entirely. Teams are no longer asking if they can use anything, but are instead asking which approved options fit the workload. That is the right framing. In a rooted architecture, switching models is not a minor detail because it affects cost, latency, safety, and even the quality of downstream handoffs. If one expert path quietly changes from one model family to another, the root may still succeed, while the system characteristics change underneath it. That is exactly the kind of drift mature governance should prevent. So start with allow lists, approved models, approved publishers, approved deployment patterns. If your organization wants different options for different contexts, that's fine, but you have to define them centrally. Maybe development gets a broader catalog for experimentation, while the test environment narrows that list down. Production should only permit a smaller set of fully reviewed models to ensure the architecture doesn't turn into a moving experiment. And one level deeper, routed systems make this more urgent than single model systems. In a single model setup, one bad decision only affects one primary path, but in an expert fabric, a loose policy can create dozens of unstable combinations. The router model changes, the specialist model changes, and the fallback model changes until the system is no longer one governed service. It becomes a collection of shifting dependencies. Azure policy helps you compress that sprawl back into an approved operating boundary. The research also points to another useful idea where dynamic model switching is still possible inside the approved catalog. That is the balance. You do not need to freeze the architecture completely because you can still build cheap first patterns that escalate later. One root can still select between approved models based on the task type or the environment as long as the evolution happens inside a bounded space. The policy does not kill routing, but it does make routing governable. This also creates a cleaner relationship between platform teams and builders. Platform teams own the model catalog and the rules around what gets approved. Builders design workflows and expert paths using that catalog. Security and compliance teams review additions to the catalog instead of chasing unknown deployments after the fact. That division of labor is healthier than asking every project team to invent its own model risk posture. Now, policy alone is not enough. You still need supporting controls around it because being approved does not mean a model is affordable at scale. Content filters and guardrails should sit beside model policy to ensure safety in every context. Traceability is also required so you can actually observe the traffic once it starts moving. Policy sets the boundary, but these other controls make that boundary operational. And there is one more reason to care about this. When a route performs badly, teams often blame the model, but sometimes the real problem is that too many models were allowed in without any disciplined evaluation. Once model choice is governed, you can finally test the route on purpose, which is exactly where we need to go next. How to evaluate routing, not just model quality. Once you add routing, the unit you need to test is no longer just the model. It is the decision system. That sounds obvious, but a lot of teams still evaluate routed architectures as if the only meaningful question is whether one output sounds better than another. In a rooted setup, the first failure may happen before the final answer is even generated because the router might choose the wrong path. It may escalate too often or avoid escalation when it shouldn't, and sometimes it sends work to the right expert but with the wrong structure. If you only score the final response, you are measuring the last visible step and ignoring the logic that shaped it. Start with a baseline. Take your current fixed model setup and measure it honestly for quality, latency, cost, and task success. Then compare the rooted design against that baseline using a representative workload rather than a polished demo set. You need a set of real requests that reflect what users actually do, including messy phrasing, ambiguous asks, and the routine traffic people complain about later. Representative matters because routing systems are extremely sensitive to traffic shape. If the test set is too synthetic, the router may look cleaner than it really is. But real users don't write benchmark prompts. They write partial sentences, mixed requests, and vague questions with too much context or too little. A good evaluation set has enough variation to show where the route starts bending under pressure. Then measure 4 things together. Quality is 1, cost is another, latency is another, success rate is the 4th, and it is often the most grounded measure in enterprise systems because it reflects whether the request was actually completed. A route that saves money but lowers completion quality is not a win for the business. A route that improves answer quality but destroys latency on common tasks will also fail in practice, which is why these systems need multimetric evaluation. You also need trace-based evaluation. This is much more useful in agent systems than isolated prompt scoring, because traces show how the route actually behaved. You can see which path was selected, which expert was called, and whether retrieval or a specific workflow was used. Without traces, you are mostly guessing why a result happened, but with them, you can learn if the problem came from routing or specialist behavior, and then look at distribution. Where is the traffic really going? This question matters more than people expect because a routed system can look elegant on paper and still fail economically. If too much traffic ends up in premium paths, or if the system clings to low-cost paths too aggressively, the architecture will underperform. Inspect the model distribution after test runs to see what percentage stayed cheap and which domains triggered fallbacks most often. Distribution tells you whether the architecture you designed is the architecture you are actually running. Approval thresholds should come before production, not after. Define what acceptable looks like before you roll anything out to users. Maybe the routed system must preserve task success within a narrow range while cutting cost, or perhaps the P95 latency cannot exceed a certain limit. The exact thresholds will vary, but the discipline is the same because you have to decide the gate before the rollout. Otherwise, teams will just keep adjusting their expectations after they see mixed results. And one more thing, evaluate the router itself, not just the whole chain. Take labeled examples and check whether the router picked the intended path so you can measure misroutes separately from specialist failures. If the route is wrong, tuning the expert won't fix the system, and you need to know exactly where the miss happened. Because once routing becomes explicit, evaluation has to become architectural too, and only after you trust the route can you decide something even more important, when the system should escalate. Escalation logic is where good architectures become great. This is the point where an expert fabric either finds its discipline or turns into a very expensive maze. Routing by itself is never enough. The system needs to know when a cheap path should stop, when a stronger path should take over, and when no autonomous path should be trusted at all. That judgment is escalation logic. In practice, this is where professional architectures separate themselves from impressive demos. Most teams think about escalation too late. They build a cheap first flow, add some specialists, and wire in a larger model for hard cases while hoping the system will just know when to move upward. It won't. If your escalation rules are vague, one of two things usually happens. Either the system escalates far too often, which destroys the savings you designed for, or it escalates too rarely. That means weak results keep slipping through cheap paths that were never meant to handle that much ambiguity. So you have to define the triggers clearly. Confidence is one trigger, but it cannot be the only one. A model sounding confident is not the same as a task being safe. You also need ambiguity thresholds. Is the request underspecified? Does it combine multiple goals? Does it cross domains? Does the retrieval evidence conflict? Then add risk thresholds. Is the user asking for an action with compliance, financial, HR, or legal impact? Does the system need to write back into business data? Does it involve sensitive content or policy interpretation? That combination matters because escalation should reflect business reality, not just model uncertainty. A system might feel highly confident about a low-quality answer in a high-risk workflow, and that still should not pass. On the other side, a mildly uncertain classification in a low-risk path may not justify premium inference at all. Your design has to combine model signals with policy and business value because technical confidence alone is too narrow. In a healthy architecture, escalation works like a ladder. Simple requests stay on low-cost paths. Harder requests move to a larger model or a deeper specialist chain. High-impact actions pause for human review. That last step is easy to skip when teams want autonomy to look impressive, but it is also where a lot of preventable risk enters the system. If an action changes records, triggers approvals, moves money, or commits something externally, human approval should stay in the design. The workflow only earns more trust through long, measured evidence. And keep the escalation output structured too. When a lower tier escalates, it should not just throw the whole problem upward with a vague message that it isn't sure. It should pass a clean package. What it saw, why it escalated, what evidence it found, what path it already attempted. That preserves context, reduces repeated work, and makes review faster for both larger models and humans. There's also an economic rule here. Cheap first, expensive last. Not because cheap is always better, but because the architecture should spend capability with intent. Premium reasoning should be a deliberate exception path, not the default emotional reaction to uncertainty. If the system cannot hold that line, the route may be technically elegant while remaining financially useless. So watch for over-escalation. This is one of the most common hidden failures in routed systems. Early tests look good because the system appears safe and polished, but under the surface, almost everything drifts upward into premium paths. Cost climbs, latency stretches. Teams still tell themselves they built a small model-first architecture. They didn't. They built a premium system with a decorative front filter. The fix is not just tighter thresholds, It is better task design, narrower experts, cleaner outputs, better evidence packaging, more explicit business rules. Escalation improves when the lower paths are designed to fail clearly instead of failing messily. If you want the architecture to stay useful and governable, treat escalation as a first-class design object. Define it, measure it, review it. Every savings model, every latency target, and every safety promise in an expert fabric eventually runs through that decision about what happens next. Once you see that, cost stops looking like something attached to inference alone. It starts showing up in every layer of the system. The full cost stack of an expert fabric. Now we need to get more honest about cost. Once people accept cheap first routing, they often swing too far in the other direction and pretend token pricing is the whole story. It isn't. Token pricing is only the visible part. The system cost sits across every layer that makes the fabric work. Start with inference. Yes, you still pay for router calls, specialist model calls, fallback model calls, and sometimes verification or summarization at the end. That matters. But in a real Microsoft environment, that is only one line in the bill. The moment you operationalize the fabric, more cost surfaces appear, and some of them grow quietly. Workflow execution is one of them. If Copilot Studio hands work into Power Automate, external APIs, or connected business systems, every interaction can trigger additional runs, connector usage, and downstream compute. In a monolith, you might waste premium inference. In a fabric, you may reduce that waste but increase orchestration activity. That is not automatically bad, but it means the comparison has to be honest. Storage is another piece. Traces, logs, prompt records, retrieval indexes, and evaluation datasets all need to live somewhere. If you are doing this properly, you are also retaining enough evidence for audit, review, and incident analysis. Governed systems store more than optimistic prototypes do. That adds cost, but it also buys control. Then there is support cost. Who reviews escalations? Who tunes routes? Who maintains expert charters? Who updates model allow lists? Who validates connectors after business system changes? Who investigates strange traces? In a monolithic setup, waste hides inside one oversized model path. In an expert fabric, part of the spend moves into platform operations. That trade can still be very favorable, but only if the workload volume and business value justify the added discipline. So the right comparison is not monolith versus orchestration overhead in isolation. It is monolith waste versus orchestrated efficiency plus operational burden. That is a more serious equation. A single model design often looks cheaper at first because the architecture diagram is smaller. Fewer parts, fewer routes, fewer owners. But that simplicity can be fake if high-volume traffic keeps hitting expensive inference paths, weak answers create rework, and governance gaps generate manual cleanup later. The bill is not just what Azure or OpenAI charges. The bill is also what the organization absorbs when the system behaves badly or inefficiently. On the other side, an expert fabric can absolutely become overbuilt. Too many agents, too many hops, too many thin specialists that barely justify their own existence, too much logging with too little use, too much ceremony for low-value tasks. That is why architecture discipline and cost discipline are really the same thing here. If an expert path exists, it should earn its place. If an orchestration step adds latency and admin work without improving quality, safety, or savings, remove it. Volume changes the picture fast. High-volume systems usually benefit first from an expert fabric because repeated low-complexity traffic is where routing and specialization pay back quickly. Classification-heavy flows, policy lookup, extraction, and templated support are all good examples. The more routine traffic you divert from expensive paths, the more the structure starts working in your favor. Low-volume systems are different. If the request count is modest, the task variation is still fuzzy, and the team is small, orchestration overhead may outweigh inference savings for a while. In that case, the right move may be a simpler architecture with one bounded model path and strong guardrails, at least until the workload becomes clearer. So the cost question is never just, what is the cheapest model? It is, what is the cheapest system that still delivers the right outcome under governance? That is the level leaders need to design at. Because if you only optimize token price, you can still build an expensive machine. And if you ignore token price, you will definitely build one. The hidden risk of emergent behavior. There is one risk that does not show up when you test agents one by one. It only shows up once the system starts interacting with itself. This is the part many teams miss, because each individual component looks reasonable in isolation. The router behaves, the policy expert behaves, and the workflow expert follows the rules. But when those pieces start handing work back and forth, new behavior appears that nobody designed. That is emergent behavior. And in multi-agent systems, it is a structural issue rather than a fringe one. What makes it dangerous is not drama, it is accumulation. A small routing preference becomes a pattern. A pattern becomes a norm becomes the default path through the system, even if nobody intended for it to harden that way. That can look like delegation loops where agents keep passing work along because each one finds a reason to defer. It can look like tool cascades, where one decision triggers a tool call that triggers another, until the cost and complexity drift far past the original request. It can look like rubber stamping, where one specialist confirms another without adding any real check, or norm drift, where agents slowly become more permissive because the system keeps treating that behavior as acceptable. That is why testing a single prompt is never enough. A single prompt tells you if one agent can answer one question, but it does not tell you what happens after 30 handoffs and repeated retries across a live environment. The system behavior lives in the interaction pattern, not just in the text any one model returns. This is also where a lot of false confidence comes from. Teams see safe outputs from each agent and assume the whole system is safe. But local safety does not guarantee system safety. An individual agent can follow its instructions and still contribute to a bad collective outcome. One agent may escalate correctly, while another interprets that escalation too broadly, and a third takes that interpretation as evidence that the task is approved. No single step looks catastrophic, the chain does. So the controls have to operate at the system level. Start with chain limits. Decide how many handoffs are allowed before the system stops for a review, or how many tools can be called in one uninterrupted path. These are not cosmetic settings. They are boundaries that stop small feedback loops from turning into expensive or risky behavior. Then add kill switches. If a route starts producing abnormal handoff volume or strange tool usage, the platform needs a way to pause that path immediately. The research around agent governance is very clear on rapid revocation and containment, because in these environments, recovery speed matters as much as prevention. You also need anomaly detection. This is not just for security events, but for behavioral drift. You have to watch if one route is escalating more than expected, or if a specialist is suddenly touching datasets outside its normal pattern. If an approval chain becomes automatic even though humans are still in the loop, those are system signals that someone has to monitor. Role separation helps too. Do not let the same agent propose, approve, and execute high-impact actions through minor variations of the same path. Keep analysis separate from authorization and recommendation separate from writeback. That friction is healthy because it reduces the chance that convenience becomes pseudo-autonomy. And for the highest risk workflows, keep human anchoring in place, not because humans are faster, but because humans are the only layer that can step outside the logic of the chain and ask if the chain itself still makes sense. Once agents start reinforcing each other, that outside judgment becomes more important. So this is the deeper governance lesson. Emergence is not a prompt problem. It is a system problem. And if the risk is systemic, the answer cannot live only inside isolated prompts. The answer has to live in the topology, the limits, the monitoring, and the ability to stop a path before the system teaches itself the wrong habit. Which is exactly why the next design question is not just what the agents say, but how the topology between them is shaped. How to design safe multi-agent topology in Copilot Studio. So now we get concrete. If emergent risk is shaped by topology, then topology cannot be an afterthought in Copilot Studio. You have to decide upfront how agents relate to each other, who speaks to the user, and which permissions apply in each environment. If you leave those choices loose, the platform will still let you build something, but it will be harder to test and much easier to misread later. Start with one orchestrator, one user-facing voice. That pattern matters more than it seems. Copilot Studio now supports multi-agent orchestration, but that does not mean every specialist should be a peer chatbot exposed directly to the user. In most enterprise cases, that creates noise through different tones and different assumptions. The cleaner pattern is one parent agent at the surface with a set of bounded specialists behind it. That parent agent owns the conversation. It receives the user request, keeps the interaction coherent, and decides when to call specialists. The specialists do not negotiate with the user in public. They operate more like internal tools with domain intelligence. They return work products, and the orchestrator decides how those results become a response or an action proposal. That design reduces a lot of confusion. It also reduces cross-agent prompt bleed because the user is not bouncing between multiple conversational identities with overlapping roles. One front door, one visible context owner, everything else stays structured behind it. Inside that topology, specialist agents should return structured outputs, not long prose, not brand new conversations, structured outputs. That is important in Copilot Studio because orchestration works better when the downstream result is predictable enough to branch on and validate. A policy specialist can return a decision and its constraints, while a workflow specialist returns action status and execution detail. Once the output stays structured, the parent agent can combine it safely without guessing what the specialist meant. Knowledge and connectors should also be segmented by role. This is where topology and governance meet directly. If a specialist is supposed to answer benefits questions, give it the benefits corpus and only the connectors it actually needs. Do not let every sub-agent inherit a broad shared data surface just because they live under one parent. The topology should reflect separation, not erase it, and keep state outside the model where control matters. Conversation flow can use conversational context, but approvals and execution records should be stored in managed systems. Dataverse or SQL exist for a reason. If critical state lives only inside transient agent context, you lose auditability and operational control. Externalized state makes the topology inspectable. That is what you want. Environment design matters too. Development, test, and production should not just be copies with different names. They should have different permissions and different connector scopes. Development needs flexibility, while production needs tight control. If every environment can reach the same systems with the same authority, you are not really separating risk, you are only renaming it. This is also where maker freedom needs guardrails. Copilot Studio makes it easy to connect tools and agents, but safe topology means the patterns are opinionated. Parent agent at the front, specialists behind, narrow tools, and managed state. If teams drift too far from those basics, the architecture starts widening again and the governance work begins to thin out. So the goal is not maximum agent interaction, it is disciplined interaction. Enough specialization to improve fit, enough structure to keep control, enough separation to make failure containable. And once that topology is in place, you can stop talking about abstract patterns and finally show how to build the first practical version of this in the Microsoft stack. Practical build path in Copilot Studio and AI Foundry. So what does the first real build look like if you want to do this without creating a giant architecture project on day one? Start with one front door agent in Copilot Studio. Not 3, not 10, 1. That agent should own the user interaction, the channel presence, and the orchestration logic at the surface. It should know how to collect context, apply basic policy checks, and decide when to call something behind the scenes. Keep the mission narrow, one business scenario, one user group, one entry path. If you start with a vague enterprise assistant, you'll rebuild the same generalist problem with better branding. Then connect intelligence behind that front door through AI Foundry. There are two practical patterns in the research. One is bring your own model prompts in Copilot Studio, where a prompt tool connects directly to an Azure AI Foundry model endpoint. The other is connecting to external or Foundry agents through supported endpoints and Entra-based access patterns. Which one you choose depends on how much logic lives in Foundry. If the backend need is mostly model access, bring your own model is enough. If the backend needs multi-step reasoning, tool use, or agent logic, push that into Foundry and let Studio call it. That split matters, because a lot of teams put complex reasoning directly into Copilot Studio prompts and then wonder why the system becomes hard to test. Studio is strong at orchestration, channels, and workflow composition. Foundry is stronger where model control, evaluation, routing, and backend reasoning need more structure. So for the first practical version, build the backend experts in Foundry. Use prompt flow if the expert needs a chain of steps, tool calls, or controlled input and output handling. Use Foundry agent logic if the expert behaves more like a bounded specialist service with its own internal actions. In both cases, keep the output structured and narrow. The Copilot Studio parent should receive something machine-friendly first, then turn that into the user-facing response. Now make the first expert the router, not the final answer generator. This is the shortcut most teams skip, and it is where the economics of the whole design start. Use a small, low-cost model path first to classify the request. Domain, complexity, risk, action type, whether retrieval is needed, whether no model is needed at all. If the request is just a deterministic workflow trigger, route directly to the workflow. Do not pass every sentence through premium inference just because AI is available. Then add 1 or 2 specialists behind that router. That is enough for a serious pilot. For example, 1 knowledge specialist and 1 workflow specialist, or 1 policy specialist and 1 extraction specialist. The point is not to show variety. The point is to prove that the route improves fit. If you cannot show value with a router and 2 bounded specialists, adding 6 more will only hide the problem. Data should come in through approved indexes and narrow scopes. If the specialist needs retrieval, connect only the corpus that belongs to that role. If the route needs a SharePoint-backed knowledge path, scope it deliberately. If a workflow needs Dataverse or another connector, limit the rights to what that workflow needs. This is where many early pilots go wrong. They prove the user experience by quietly overexposing data, and then governance has to unwind the pilot later. Do the opposite. Constrain early. That forces the architecture to stay honest. Before you publish anything, evaluate the route and the outputs together. Use representative prompts, inspect traces, confirm where traffic goes, check whether the router is classifying the request types you expected. Look at latency across the end-to-end path, not just the model call, and make sure policy, logging, and ownership are in place before production publication. A working demo is not the same thing as a deployable service. So the practical sequence is simple. 1 front door Copilot Studio agent, 1 cheap routing layer, 1 or 2 backend experts in Foundry, narrow data scopes, structured outputs, evaluation before release. That is enough to move from theory into a governed pattern without pretending you need a massive agent estate on day one. And that matters because the right first architecture is not the most advanced one. It is the one your organization can actually operate, review, and improve without losing control. Maturity model from pilot to enterprise fabric. At this point, the biggest mistake is assuming the architecture has to appear fully formed on day one. It shouldn't. A mature expert fabric is not a starting position. It is a progression. And if teams skip that progression, they usually build too much too early, add governance after the fact, and end up managing complexity they have not earned yet. So the useful question is not, what is the perfect end state? It is, what stage are we actually in, and what does the next responsible step look like? Stage 1 is the narrow pilot, 1 agent, 1 fixed model, 1 bounded task. Not because that is the final answer, but because it gives you a clean baseline. You need to know the workflow, the failure modes, the user behavior, the data needs, and the operational burden before you multiply paths. If the task is still fuzzy at this stage, that is a warning. It means your expert boundaries are not ready yet. A pilot should reduce ambiguity, not scale it. Stage 2 is where routing starts to enter. Add a cheap router and one premium fallback. That is the first meaningful architectural shift because now the system begins distinguishing between common traffic and difficult traffic. It is still manageable. You are not running a network of specialists yet. You are proving that cheap first logic works in your environment, with your users, on your workload. This is where you learn the basics of route accuracy, escalation behavior, and cost distribution without taking on full multi-agent governance. Then comes stage 3. Multiple specialists with governed handoffs. Now the architecture starts behaving like a real expert system because the route no longer just chooses between cheap and expensive. It chooses between different kinds of work. A knowledge path, a workflow path, a policy path, maybe an extraction path. At this point, ownership matters more. Logging matters more. Connector discipline matters more. You are no longer just optimizing model spend. You are shaping a controlled operating structure. And because handoffs now affect quality and risk directly, each specialist needs a clear charter and a clear stop boundary. Stage 4 is the enterprise fabric. That means policy-controlled model catalogs, lifecycle reviews, telemetry, environment discipline, central inventory, and an operating model that clearly separates platform ownership from domain ownership. This is where Agent 365, Azure policy, trace-based evaluation, and cost governance stop feeling optional. The architecture is wide enough now that without those controls, drift becomes normal. So stage 4 is not more agents. It is stable coordination across agents, models, tools, and teams. This progression matters because organizational readiness is just as important as technical readiness. A team may be able to build a multi-agent demo in a week. That does not mean the organization is ready to own one in production. Do you have a model approval process? Do you have named owners? Do you have logging standards? Do you have a place to review incidents? Do you know how to revoke access quickly? If the answer is no, then your architecture maturity is lower than your prototype maturity, and that gap becomes dangerous fast. This is why I would always match the target design to the current operating discipline. If governance is still immature, stay closer to stage 1 or 2. If the workload is high volume and well understood, move into stage 3 with care. If multiple business units are already building agents and the platform team can provide controls, then stage 4 starts making sense. But don't romanticize the end state. Enterprise fabric is not automatically better just because it is bigger. It is only better when the next layer of structure solves a real problem that the previous layer could not handle cleanly. So the practical rule is simple. Prove the first route before you expand the map. Prove the first specialist before you add 3 more. Prove the first governance gate before you depend on 10 of them. That pacing keeps the architecture honest. It also prevents teams from turning future ambition into present complexity. And once you see maturity that way, one final design question becomes much easier to answer. When should you not build a mixture of experts at all? When not to use a mixture of experts. Now we need the counterweight, because once people understand the expert fabric, they swing too hard. They start treating it like the default answer to every AI problem. It isn't. A mixture of experts is a structural answer to a specific kind of complexity. If that complexity isn't there yet, the structure just becomes overhead. The first case is low volume. If your request count is small and the task is stable, a rooted architecture solves a problem you don't actually have. The design might look cleaner on a whiteboard and specialist boundaries sound mature, but the math doesn't always work. If the workload only sees limited traffic, the savings from routing will never outrun the cost of building and testing those extra moving parts. In that situation, one well-bounded model with clear prompts and strong review discipline is usually the better decision. The second case is low risk. If the agent isn't touching sensitive data or triggering business actions, heavy orchestration is often unnecessary. You still need controls and ownership, but the full fabric might be more structure than the situation demands. A simple architecture isn't a failure if it fits the task. Actually, that's usually the more responsible choice. Variation matters too. If the team is still learning what users want, your expert boundaries will be weak because the task itself is moving. When boundaries are weak, specialists start overlapping, and one agent ends up handling the same work as another. Escalation rules get fuzzy and routes become unstable because the categories underneath them aren't settled yet. That's a sign to pause and simplify. Before you create multiple experts, make sure the work actually separates into distinct categories. Small teams need to hear this clearly. A multi-agent system creates ongoing obligations that don't go away once the code is written. Someone has to maintain the prompts, someone has to review the traces, and someone has to update the connectors and policies. If the team doesn't have the capacity to run that operating model, the architecture becomes fragile very quickly. You don't get maturity just by drawing more boxes. You get it by sustaining the controls around those boxes over time. Governance maturity is another real limit. If your organization still struggles with basic ownership or permission hygiene, adding more agents increases risk faster than value. The system might look advanced, but underneath it, the same old weaknesses stay in place. Unclear owners, broad access, missing logs. In that condition, the right next step is to strengthen the platform baseline before you start multiplying specialists. There is also a temporary case where one strong model is simply the smarter answer. If the workload is broad and the task design is still emerging, one capable model gives you a cleaner learning period. You gather evidence and see which requests repeat, which helps you discover where real specialist boundaries might eventually sit. That isn't anti-architecture, it's sequencing. Sometimes the shortest path to a good expert fabric is starting with a simple setup and only splitting it once the patterns are obvious. Another warning sign is when people want a mixture of experts mainly because it sounds sophisticated. That leads to decorative specialists and experts with weak missions. Those roots exist because the architecture team wanted elegance, not because the users actually needed it. If a specialist cannot explain its unique role and its unique data scope, it probably shouldn't exist yet. So the real decision rule isn't more agents equals more maturity. It's fit. Use a mixture of experts when workload, shape, cost pressure, and governance capability all point in the same direction. Hold back when they don't. The point isn't to replace every single model system on principle. The point is to stop forcing one model to do jobs that clearly need different treatment. And that brings us to the final layer. Because even when the architecture is right, it only holds if the organization knows who owns what. The operating model behind the architecture. Now we get to the part that decides whether any of this survives. Because architecture on paper is easy. Operating it is where the truth shows up. An expert fabric doesn't run on prompts alone. It runs on ownership. If ownership stays blurry, the system drifts back toward the same confusion we started with, just spread across more components. So split responsibility on purpose. The platform team should own the guardrails. That means the model catalog, the routing standards, the policy controls, and the observability stack. They aren't there to write every expert prompt or babysit every business workflow. They are there to define the safe operating envelope. Which models are approved, which deployment paths are allowed, which traces must be captured. Without that platform layer, every domain team rebuilds governance differently, and the fabric fragments almost immediately. Then domain teams own the experts, not the whole platform. They're experts. That includes the expert charter, the prompt logic, the data boundaries, and the escalation rules for their specific process. If an HR policy expert exists, the team accountable for HR should own whether that agent is correct and useful. If a finance workflow expert exists, finance operations should define what the agent can recommend and where human review sits. This is where a lot of AI programs fail. They centralize everything in one technical team, and then the specialists stop being real specialists because the business never truly owns them. Security and compliance sit beside both groups, not underneath them. Their job isn't to become the routing designer. Their job is to review controls, map risk, and make sure the fabric can be defended when something goes wrong. In a multi-agent system, incidents are rarely neat. You need predefined response paths. Who pauses an agent? Who revokes access? Who decides whether a route goes back online? If those answers only exist informally, the first serious problem turns into organizational improv. Finance and operations also need a real seat here. Once you move into a rooted architecture, spend has to be measured per outcome, not just as one total AI bill. You need to know which expert path costs more and which domain escalates too often. If finance only sees aggregate spend, the architecture becomes hard to improve. Cost needs to map to behavior. That's how you see whether the structure is actually working. This is exactly why a center of excellence pattern helps, provided it's done properly, not as a vanity committee. As a working review layer, the COE can publish templates for expert charters and route design so teams don't solve the same problem 5 different ways. It shortens the path between innovation and control because teams don't have to invent the model from scratch every time. But the COE should not become a bottleneck that owns everything. If it owns everything, domain ownership collapses again. The healthier pattern is shared structure, local accountability. Platform defines the rails. Domain teams drive the mission. Security validates the controls. Finance tracks value and waste. The COE helps the whole system stay consistent. And one level deeper, this is why the architecture changes behavior only when ownership is explicit. A routed system is really an operating model for decision-making. It decides who is allowed to define expertise and who is responsible when a route fails in production. If those lines are clear, the fabric can evolve without dissolving. If those lines are weak, every new expert adds ambiguity instead of capability. So after all of this, the shift is bigger than model choice. You are replacing a generalist bot with a managed system of bounded responsibilities. And that is the actual promise we opened with. The shift is simple, even if the build is not. Stop treating one generalist bot like the answer. Start designing a governed fabric. Copilot Studio handles the experience. Foundry handles the intelligence. Small models root the work. Specialists do bounded jobs. If this changed how you think, follow me, Mirko Peters, on LinkedIn. And if you want more of this, leave a review. It helps more people find it. Tell me where your architecture is breaking, or tell me what comes next. Routing, Agent 365 governance, or cost design.